Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have the function y equals natural log of x minus 1 and we have to sketch a graph of this function. So, you have to sketch a graph. In order to do that, we can just construct a table and plug in some x values and get the corresponding y values and plot those points in our xy plane and then graph it. Before we start the table, please recall that this is a natural log function and an ln function is not defined for every x values, but it is defined only for positive values. And therefore, we have to be careful about the domain of this function first. We can't just plug in any x and want an output. So, what is the domain of this function? So, the domain is again for positive values. So, how to compute the domain? You see the expression that is inside the function x minus 1, that has to be positive. And this means x has to be greater than 1, strictly greater than 1. So, we can plug in values that are strictly greater than 1, not including 1. Okay. So, now let's construct a table. Right. So, we have x here and we will plug in y. We'll plug in x and we'll find out what y is. Notice y is ln of x minus 1. So, let's choose some values greater than 1. Let's say start with 1.5. So, how do we figure out this value? Well, plug in 1.5 for x. So, we get ln of 1.5 minus 1 and that's ln of 0.5. And to be able to graph it, we will need to know what an approximate value is for natural log of 0.5 and we'll use a calculator to figure those values later. But let's move on and pick some other values for x first. So, let's say the next one is 2. For x equals 2, we have natural log of 2 minus 1. So, that is natural log of 1 and as you know, natural log of 1 is 0. So, we know that value already. Okay. Let's plug in 2.5 for x. So, we get natural log of x minus 1. So, 2.5 minus 1, that is natural log of 1.5 and we have to figure that value again. Let's choose 3 for x. So, we have natural log of 3 minus 1, which is natural log of 2. Let's plug in 3.5. So, natural log 3.5 minus 1, which is natural log of 2.5. And finally, let's plug in one more point. Let's plug in 4. So, we get natural log of 4 minus 1, which is natural log of 3. All right. Now, we have to use a calculator to figure out all these values for an approximate and then we can plot them. So pick a calculator. Okay, so the first value, don't look at the x, look at ln of 0.5. Look at this bottom number and plug in 0.5 for natural log, and you get approximately it's negative 0.69. The second value we already know is 0. Okay, for the third, you plug in natural log of 1.5, not the 2.5, remember. Okay, so the value is 0.41. When x is 3, you have to figure out the value for natural log of 2, and that is 0.69. For 3.5, we have to find out natural log of 2.5, and that is 0.92. For the last value, we have natural log of 3, which is about 1.1. So we complete our table, and let's plot these points on the graph on the xy coordinate plane and then graph it. Now look at our values. These are decimal, and then we go up to 1.1. So let's say we do the scale, say 0.2, 0.4, 0.6, 0.8, 1, 1.2, 0.4, negative side, 0.2, negative 0.4, negative 0.6, negative 0.8, and so on. And here, so this is 1, 2, 3, 4, 5. Okay, so the first point is 1.5 and negative 0.69. So here we have 1.5, and we go to negative, almost like negative 0.7. So it's about here. At 2, we have 0. At 2.5, we have 0.4. So 2.5, 0.4. 3 is about 0.7. So 3 will be 0.7. 0.7 is in between here. So about here. 3.5 is 0.9. So 3.5 is close to 1 here. And 4 is 1.1. So about here. So roughly, so if you join these points, you will get a rough sketch of the graph. And let me point out one more fact. See, at x equals 1, the function is not defined because natural log of 0 is not defined. But as x is approaching to 1 from right side, this function will continue to go downward. So it will be approaching to negative infinity. And therefore, this x equals 1 is going to be a vertical asymptote to the graph of the function. So let me point that out here in the graph. X equals 1 will be actually a vertical asymptote, and the function will keep decreasing and get close to that line. So that is a rough sketch of the function natural log of x minus 1. Thank you.